In this video, I will explain how to solve trigonometric equations using the formulae. We start by considering the sine graph, which is a wave that repeats every 360 degrees. We say that its period is 360 because within a span of 360 degrees, we see the full nature of the wave. The maximum point is at 1 and the minimum point is at -1. So if we are asked to solve the equation sine theta is k, then k must be between -1 and 1. If it's greater than 1, then we have no solutions. And if it's less than -1, we also have no solutions. So suppose we need to solve sine theta is √3/2. So if I draw a horizontal line cutting the y-axis at √3/2, I'm pretty much asking to find the points of intersection with the sine wave. So all of these points here. Well, my calculator is good enough to provide me with an initial value. I call this the principal value. So PV is shift sine of √3/2. So I plug this on the calculator. I get a value of 60. That's 60 degrees. So I know that this is 60 degrees over here. So the question is, how can I use the 60 degrees from the calculator to generate the rest of the solutions? I can see through symmetry that this here must be 180 minus 60 because the distance that 60 is to the right of 0 is equal to the distance that 60 is to the left of 180. So a second solution would be 120 degrees. We can then exploit the periodicity of the sine wave by going 360 degrees to the left and to the right of the 60 degrees, or 360 degrees to the left or right of the 120 degrees in order to generate more solutions. So looking at the graph, we can see that theta could be 60, or 180 minus 60, or it could be 60 plus 360, or 120 plus 360, or if I deduct 360, it could be 60 minus 360, or 120 minus 360. So this means that we have 6 cuts here. We've got 6 solutions, and they are 60, 120, 420, 480, minus 300, and minus 240. Now I can generalize all of these by simply considering that with my PV, my principal value, I've got one solution, and the second solution will be 180 minus the PV, and I can add or subtract multiples of 360, multiples of the period, which leads to the formula that PV plus 360k, or 180 minus PV plus 360k, will give me all of the solutions. Now PV comes from the calculator, and k is an integer. It could be negative, it could be 0, it could be positive. So I'm adding or subtracting multiples of the period, multiple of 360. So this is the formula if I'm working in degree mode, and if I'm in radian mode, obviously it's going to be PV plus 2 pi k and pi minus PV plus 2 pi k. Now for cosθ, it's a very similar approach. So we still have a period of 360 degrees, and we see that the wave still goes from 1 up to -1. So suppose we want to solve cosθ is a third. This simply means draw a horizontal line at a third. So we look at the points of intersection with the cosine wave. We need to determine all of these solutions here. Again, I'm going to go on my calculator. I'm going to do shift cos of a third, and I get 70.5. So the positive solution over here is 70.5, and I can exploit the symmetry of the cosine wave to see that the second solution over here is going to be the minus 70.5. Now, exploiting the periodicity once more, I can go 360 degrees to the left and right of each of these solutions in order to determine more solutions. So we can see that we've got solutions at 70.5. We've got solution at minus 70.5. Then it's 70.5 plus 360 and minus 70.5 plus 360. And then it's at 70.5 minus 360 and minus 70.5 plus 2 times 360, because I can add 2 periods, so 2 jumps of 360 degrees to get another solution. So this simplified to 70.5. We've got minus 70.5. Then it's 430.5, 289.5. We've got minus 289.5, and finally 649.5. Obviously, the number of solutions depends upon the range of values of theta. If I'm between minus 360 and 720 in this particular case, we've got a total of 6 solutions. All of this can be nicely summarized into the formulae for cosine. If I'm in degree mode, it's simply the PV plus 360k or minus the PV plus 360k. So from the 2 solutions here, I can add or subtract multiples of 360. Obviously, if I'm in radian mode, it's going to be PV plus 2 pi k and minus PV plus 2 pi k. And again, the PV is from the calculator and k is any integer. So I can substitute different values of k, and I will be generating different solutions to the given trigonometric equation. Now for tan theta, the situation is a bit different. We've got no restrictions on k because the range of values of tan theta goes from minus infinity up to infinity. We don't have the maximum of 1 and the minimum of negative 1. And also the period now is 180 degrees because between 0 and 180 degrees I see the full nature of the wave. So suppose I want to solve tan theta is negative 1. Obviously, I will draw the horizontal line cutting the y-axis at negative 1, and I'm looking for the solutions, the points of intersection between my horizontal line and the tan wave. Using my calculator, I'll find my principal value. I'll do shift tan of negative 1. I get negative 45. There it is. And then I can go to the right by adding 180 degrees and multiples of these to find more solutions, or I can even go to the left, so minus 180 degrees to get another solution. So we can easily conclude that theta is minus 45 plus 180, or minus 45 plus 2 times 180, or minus 45 plus 3 times 180. I can even go once more, so minus 45 plus 4 times 180, or minus 45 minus 180. So this gives me a total of 6 solutions. It's minus 45, it's 135, it's 315, 495, 675, and minus 225. So the formula for tan is simply PV plus 180k if I'm in degree mode, and PV plus pi k if I'm in radian mode. Now let's see a few examples. Let's start with sine theta is a half. Theta is in degrees. It's between minus 360 and 360 over here. So I will start by finding my PV. So the PV is going to be shift sine over half. This gives an answer of 30 degrees. So I go to my formula for sine. Theta will be the PV 30 plus 360k, or 180 minus 30 plus 360k. And I will be substituting different values for k. If I put k to be 0, I get theta is 30 or 150. If I put k to be 1, I get theta to be 390, the 30 plus 360, or 510, which is the 150 plus 360, so 510. I could put k to be negative 1, and I get theta to be minus 330 or minus 210. I will pick the solutions that lie between minus 360 and 360. So theta is minus 330 or minus 210 or 30 or 150. The second example is on solving cos theta is root 2 over 2. And again, I will start by saying my PV will be shift cos of root 2 over 2, which gives me an answer of 45 degrees. So theta is going to be plus minus the PV of 45 plus 360k. So if I put k to be 0, I get theta is 45 and minus 45. If I put k to be 1, I get theta to be 405 or 315. If I put k to be negative 1, I'll get theta to be 45 minus 360, which is minus 315, or minus 45 minus 360, which is minus 405. I'm going to list those solutions that are between minus 360 and 360, which are minus 315, minus 45, 45, and 315. And then we've got tan theta is root 3. I would say PV is shift tan of root 3. This gives an answer of 60 degrees. The formula for tan is just 1, PV plus 180k. So theta is going to be 60 plus 180k. And if I put k to be 0, I get theta is 60. If I put k to be 1, I get theta is 60 plus 180, which is 240. If I put k is 2, I get theta is 60 plus 180 times 2, which is 420. If I put k to be negative 1, I get theta is minus 120. And if I put k is negative 2, I'll get theta is minus 300. So my solutions are minus 300, minus 120, 60, and 240. And we will finally be looking at 2 examples involving radians. We need to give our answers to 3SF. And I will show you here how you can use the calculator to automate the process of generating all solutions. So let's start by considering the first example. We've got sine 2 theta plus 1.2 is 0.4. I will start by finding my PV. So PV is shift sine of 0.4. I will get my calculator on the right here. I will make sure that I am in radian mode. So shift, menu, I choose 2 angle unit and 2 radian, and then shift sine of 0.4. This gives an answer of 0.4115. Let me write this here, 0.4115 ... And I will store this on A by pressing the STO button and then A. So there it is, the answer has been stored on A. Well, we know that for sine, we've got 2 theta plus 1.2 is the PV, which was A plus 2 pi k, or 2 theta plus 1.2 is pi minus A plus 2 pi k. So I will solve for theta. We've got 2 theta is A minus 1.2 plus 2 pi k, and I divide by 2 to get A minus 1.2 plus 2 pi k, and all of it divided by 2. And for the second equation, we've got 2 theta is pi minus A minus 1.2 plus 2 pi k. Divide by 2 leads to pi minus A minus 1.2 plus 2 pi k, and all of it divided by 2. Now going back to the calculator, I press menu, it's option 9, the table, and for f of x, I will put exactly what I have here on the left hand side. So it's gonna be A minus 1.2 plus 2 pi x. Now x assumes the role of k, and all of it divided by 2. And for g of x, I'm going to put the second equation, so it's going to be pi minus the A minus the 1.2 plus 2 pi x, and all of it divided by 2. So I will start at negative 2, I will end at 2. I'm stepping every 1, which means substitute x is minus 2, minus 1, 0, 1, and 2. And we've got exactly what we wanted here. All of these are the solutions, and the only thing missing is for me to choose those solutions that lie within the range of values for theta. It's between minus 2 pi and 2 pi. So 2 pi is 6.28, so I'm just going to pick those solutions that are between minus 6.28 and 6.28, giving answers to 3SF. A good thing with this approach is that I maintain full accuracy throughout. I can see that the first solution is minus 5.52. So let me write this down, minus 5.52. Then I go down and to the left, it's minus 3.54. Then I go to the right, it's minus 2.38. And as I go through this, I see the next one is minus 0.394. Then it's 0.765. Then it's 2.75. And then 3.91. And finally 5.89. We've got a total of 8 solutions between minus 2 pi and 2 pi. A second example, we'll be looking at tan minus theta plus 1 is 2. So we will start as always by finding the PV. So the PV is shift tan of 2. We are in radian mode, so shift tan of 2 gives an answer of 1.107 ... which I will store on B. So let me write a B here for me to remember. And on my calculator, I press the STO button and B. So I've just stored this on B. We know that the formula for tan says the theta, so in this case it's the minus theta plus 1, is the PV, which is B plus pi K. So this means that minus theta is B minus 1 plus pi K, leading to theta is minus brackets B minus 1 plus pi K. Once more, I'm gonna go to my calculator, I press menu, it's option 9 again. F of x is minus brackets B minus 1 plus pi x and close brackets. I'm gonna leave the g of x empty, and I will start at negative 3 and maybe go up to 3, step every one, and all I see here are the solutions. Again, I'm picking those solutions that lie between minus 2 pi and 2 pi, so minus 6.28 and 6.28. So 9.318 is a solution, but not within the range. If I go down, 6.18 is one of the solutions, and then I go down and I see the 3.03. Keep going down, we see the minus 0.107. And then it's the minus 3.25, a total of 4 solutions for this particular trigonometric equation. Thanks for watching. If you found this video useful, please like it and subscribe to our channel. You can also leave a comment below to tell us what you think.